Alright guys, so welcome to my first YouTube video. This is very new to me, but we're going to give it a try. As promised, I'm going to go over the homework for today. And obviously this is the homework that I have in front of me. And I'm going to go ahead and go over question number 4, because I'm pretty sure that question number 4 is one that you guys are struggling with. Same concept, just something a little different that's going on here with the division. Obviously we always panic when we're writing. But I'm going to walk you through it so you can stop panicking for a little bit. So first of all, let's read the question. We have, Ricardo ran the 100-meter sprint in 10.5 seconds. So he ran 100 meters in 10.5 seconds. Which best represents, this is going to be very important to finding the answer. Best represents is basically asking you to give it the estimate. To give it an estimate for what it is that you're doing. Ricardo's rate in meters per second. So we're solving, and the first thing that I want to write is my rate. My ratio, of course, and then I'm solving for an equivalent ratio. So I'm going to go ahead and start setting up my stuff, my proportion, not stuff, and I'm going to start setting, what am I comparing? Well, I'm comparing meters to seconds. I'm going to go ahead and put meters on top, my numerator, and seconds on the bottom. Then my ratio of what is given to me, of what is the information that I'm going to use to help me solve for this, is that I know that he can run 100 meters in 10.5 seconds. They want to know what is his rate. In other words, how fast is he going per 1 second? We talked about this in class. I said that the word rate is sometimes used as a word for unit rate. You want to know how fast that one person is going. So then my 1, where is it going to be placed? I'm going to place it at the seconds label part, because that's what I'm solving for 1 second. I'm going to go ahead and put the 1 here at the bottom. And then you need to ask yourself, okay, well, from 10.5 to 1, what am I doing to get there? It's like we're simplifying 10.5 to 1. Every time you're trying to get to a number 1, you're trying to divide, you're always going to divide by the number itself. A number divided by itself leads you back to 1. So it's going to be divided by 10.5. 10.5 divided by 10.5 equals 1. And then 100 divided by 10.5. And this is the part that we are having such a fun time with. And I can already see, and I already had one of our classmates ask me a question before they went home. And I said, don't panic, just divide, like we usually say in class. So first of all, I have 100 divided by 10.5. So I'm going to go ahead and start setting this up. I'm going to set up my division box. The 100 always goes inside the first number, which is your total, divided by 10.5. And this is the part that some of us are having a hard time with. We discussed this a long time ago, not that long ago, maybe about 2 units ago. What do you do when you're dividing with a decimal on the outside? You cannot divide with a decimal on the outside. Okay, so what you have to do is you have to shift the decimal over to make it a whole number as many times as you need to. Well, here I only shifted 1 time to make 10.5 to 105. I'm going to do the same thing to 100. The decimal right now is an invisible decimal. It's located right here after the 100, because it's like 100.0. I'm going to shift it also 1 place. This empty place here becomes a 0. And now we can say that our new division expression is, I'm going to write it again, 1,000, because I added a 0, the decimal is now over here in this place, divided by 105 after you move that decimal here. So this division expression, you don't even need it anymore, right? So now we have that. Now I'm going to go ahead and start dividing. Well, how many times does 105, and I'm going to zoom into my division so you can have easier access to that. This, I'm adding this because I like to add this to know how many numbers I'm going to need. Well, ask yourself, how many times does, what color do we want to use? Let's use a blue. Does 105 go into 1? It doesn't, 0. How many times does 105 go into 10? It doesn't, 0. How many times does 105 go into 100? It doesn't, 0. But how many times does it go into 1,000? So this is the part that some of us might have a hard time with. What I like to do when I'm trying to divide is I like to always think about a number that's closer to 105 in this case, which would, for me, is 100. Well, I know that 100 times 10 is 1,000. So maybe 105 times, not 10, because if you do 10, it's going to go a little bit over. Let's try times 9. It's just basically trial and error, guys, using your times tables. So I'm going to go ahead and try 105 times 9. Let me see if that gets me close. From this, I'll be able to tell, do I need to go one more or need to go one less? And then we just kind of just go from there. 9 times 5 is 45. Carry the 4. 9 times 0 is 0, plus 4 is 4. 9 times 1 is 9. 945. Perfect. Because obviously if you do 10, it's going to go too much. You don't want to do less than that. So it's 105 times 9. And then I'm going to go ahead and delete this, erase this, sorry, just so I can have some space. And that was 945. I'm going to subtract that. 0 minus 5, I can't. Got to borrow. 0 minus 4, I can't. 0 minus 9, I can't. So I'm going to go ahead and borrow from the 1. That becomes a 0. The 0 first is a 10, but then becomes a 9 because I'm going to need to borrow again. That's a 9, and this becomes a 10. So this is 5. 9 minus 4 is 5. 9 minus 9 is 0, so you don't need that anymore. Now you have nothing else to bring down. So you want to add a nice decimal, bring it up, and a nice 0, and bring that 0 down. Now you're going 105 into 550. So again, let's go ahead and start to do like a trial and error. Well, I know that 100 times 5 is 500, right? And 100 times 6 is 600. So if I go 6, that's going to be too much. So let me try 105 times 5 first to see what that would give me. Let me see if maybe I need to go one more, maybe go one less. Notice how I'm not going through each and every single option. I'm simply trying to see what can get me closer, what can get me as best as possible, as close to the number that I'm trying to get to. Let's start to multiply. 5 times 5 is 25. 5, carry the 2. 5 times 0 is 0, plus 2 is 2. 5 times 1 is 1. 525. To me, I think that's perfect because obviously if you go one more, it's going to go way above 550. So then I'm going to go ahead and add one more bar here. That's going to be 105 times 5 is 525. Subtract that now. So, and then I'm gonna erase this just so I can get some more space. This is going to be now, I can't subtract 0 from 5 or 5 from 0. So I'm going to borrow from the 5, becomes a 4. That's a 10. That's 5. This is 2. Let's add one more 0 just to see where it goes. Okay, 105 to 250. Again, think about 100. 102 is 200. So let's try 105 times 2 to see what we get. This is 10. 2 times 0 is 0. Plus 1 is 1. 2 times 1 is 2. That's 210. If you go one more, you will go over 250. So this is going to be 105 times 2 minus 210. This is 0 and this is 4. You can keep going forever. But here's the thing, guys. You do not want to go more. I recommend that you stop here because remember, it is an estimate. So meaning that I can use this number now to make an appropriate estimate. So basically, which is closer to 9.52, we're going to go ahead and round. Okay, so I have 9.52 is how many meters per second that Ricardo can run, right? Well, right off the bat, I can delete 1. I can eliminate 1. And to me, that's option D. Not even close to 9.52. Okay, we're going to round though. Think about 9.52, and this is how I like to think about rounding. Think about it like as a little mountain, right? You got 9.52 here on top, which is what you're trying to round to. At the bottom, you have 9.0. And at the other side, you have 9.5, or 9.6, sorry. Okay, not 9.0, my apologies. This is 9.5. Well, 9.52 falls a little bit closer to 9.6 than 9.5. Therefore, the correct answer is A, 9.6 meters per second. It's not 9. 9.52 is not closer to 9 in any way. It's not 9.2. It is also not closer to 9.2. The only possible answer was A. So Ricardo runs approximately or estimated to run 9.6 meters per second. Okay, I really hope that this helped you. I'm gonna go ahead and just put it over here, 9.6, which is my estimate. I hope that this helped you. I hope that you're having an awesome time doing your homework. I hope that this tool will be an easier way and a better way for us to learn together. And as the YouTubers say, and I'm gonna make myself cringe, but it's okay. As they say, like, comment, and subscribe. All right, I'll see y'all tomorrow, or I will help you tomorrow on tomorrow's homework. Stay tuned on tomorrow's, what is this called? Episodes? No? Vlogs? I don't know. Homework, whatever. Okay, see you tomorrow.